Okay, so let's start the discussion. You are given a 2D zero-indexed integer array dimensions. Find all indices from 0 to the length of the array with dimensions I0, where dimensions I0 represent the length and dimension I01 represent the width of the rectangle I. Return the area of rectangle having the longest diagonal. If there are multiple rectangles with longest diagonal, return the area of the rectangle having the maximum area. So question is very much clear, or is there any doubt in the question? You are given a 2D array. Okay. In that 2D array, you are given two things, the length and width of the rectangle I. Okay. So for every rectangle, you have to tell which rectangle has the longest diagonal. Okay. And if there are multiple rectangles which have the same longest diagonal, then you have to return the area of the rectangle having the maximum area. So you have to return the area if there's a diagonal, if there's a rectangle which has a longest diagonal alone, then you have to return the area of that rectangle. Or if there are multiple rectangles which have the same length as the longest diagonal, then you have to return the maximum area out of those. So is it clear, the question?
Yes, bhai.
So there's a very good property about a rectangle, which is all the rectangles are right angle triangles, right? All the rectangles are right angle triangles. If we slice them from diagonal part, they are built up on a right angle triangle, right? This
Yes,
is
bhai.
a right angle triangle,
तो
and
डायगोनल निकाल लेंगे अंडर
right,
रूट करके.
yes, we can get the diagonals easily by taking the square root of the squares of the length square plus width square is the length of the diagonal. So simply what we'll do, we'll iterate to the array of the rectangle, okay, which has all the dimensions of different rectangles present in there. And then we'll check what? We'll check first, we'll initialize our diagonal, maximum diagonal length to be 0. If we find a diagonal with length greater than 0, what we'll do? We'll take its area as answer. Okay, and its area will be length into width. Then we'll go to another triangle, compare if its diagonal length is greater than the previous maximum. If it's greater than the previous maximum, then we'll take its area as the maximum area. Or if its diagonal's length is same as the previous maximum, then also we'll calculate the area and see what's the maximum area out of both of these. Okay. So is this question clear? Is this solution clear, or you need more explanation?
क्लियर
Okay.
हुआ.
Okay. It is clear. So then we'll move to the next question. Okay. Uh, let's move to the next question. Is my screen visible?
Yes.
Okay. So minimum moves to capture the queen. There is a one indexed 8 cross 8 chessboard. Okay. Containing 3 pieces. You are given What? You are given six integer A, B, C, D, E, F, where A, B denotes the position of the white rook, C, D denotes the position of the white bishop, E, F denotes the position of the black queen. Okay. Given that you can only move the white pieces, return the minimum number of moves required to capture the black queen. Okay. So everyone has familiarity with chess moves, how they are played.
Yes.
So see, one thing is very much clear that if uh, how does a rook move? A rook moves like this. It moves either straight, diagonal, horizontally, or vertically. So if the queen is not in the line of rook, suppose the queen is here, rook can come one step down, and in next step it can call the queen, kill the queen, right? Second, if the rook is in the same line as the queen, then it can directly kill the queen. Okay. At any other position, suppose the rook is here. So what can the rook do? It can slide down here, and from here it can attack the queen and take the queen. If it's here, it can attack the queen and take the queen. Okay, so the maximum move we'll be taking is 2 for the rook, and minimum will be 1 if it's in the same row horizontally or same column vertically. Okay, so this is the minimum move a rook will take is 1, and maximum it will take is 2, not more than that. And for bishop, what we have to check is if the bishop is taking the queen in one move. If the bishop is taking the queen in one move, then it's fine. Otherwise, bishop will also take more than one move only. Then we don't have any advantage of using bishop. We can kill it using the rook itself. Clear? Is the question clear? Okay. Okay. So this was a very simple question only, not requiring much of the use of algorithm or anything else. Now we'll move to the third question. Okay. So I would request all of you to read this third question properly, because this is again a very uh, important question and a very good question. So please give it a look. We'll discuss it in some time. All of you read this question? Done with this question? Hello? Okay. So now let's come to this question. This question seems very easy in one go, but when you think of its implementation, it seems a bit hard, but it's not that hard. You just have to apply simple mathematics, simple sets, and if you have information about sets in maths, Venn diagrams, then this problem won't be very hard to visualize for you all. But even if you have problem visualizing it, we'll visualize it here for you. Okay. So you are given a two zero indexed integer array, nums1 and nums2 of even length. You must remove n by 2 elements from nums1 and n by 2 elements from nums2. After the removal, you insert the remaining elements of nums1 and nums2 into a set. Return the maximum possible size of set S. Okay. So what is the maximum possible size of set S we can have? Ramandeep and Aniket.
Wait.
Sorry?
Basically, size of nums1 plus n. We can have maximum n.
Right. Both the arrays we have of length n. Then what we are doing? We are removing n by 2 elements from nums1 and n by 2 elements from nums2. Okay. After the removals, what we do? We insert the remaining elements of nums1 and nums2 into a set S. Okay. So these elements we have removed. So how many elements are still remaining in nums1 and nums2? N by 2 and n by 2. And it is given that n is even. So n by 2 will also be a proper natural number only. So n by 2 plus n by 2 will be again n. So we have we can have at max n elements into S, the final set S. How? If the elements here are unique with these elements. Okay, so these two don't have any common intersection, then we'll have a set of size n. Is it clear? Is it clear or you have any doubts? Aniket, Ramandeep?
Clear. N and maximum size can be n.
Okay. Okay. So now let's come to some examples and see what this question is trying to teach us. Okay. So here in the very first example, what we have got array 1, nums1 with elements 1, 2, 1, 2, and second array has elements 1, 1, 1, 1. So what is the maximum size of the set S we can have? So here we see that in this array we don't have any option. Whatever two elements we remove, we'll have 1, 1 as the remaining elements. Here we have some three options. Either we remove both 2 and we have 1, 1 as the remaining part of the array. We remove we remove 2, 2 and we have 1, 1 remaining in the array. Then we remove 1, 1 and have 2, 2 remaining in the array. Or we remove 1, 1 and 1, 2 and have 1, 2 remaining in the array. So these three scenario can be present in the first array, and this scenario is the only possibility in array 2. Is it clear? Hello, is it clear? Or do we have any other possibility also?
Clear.
Do we have any other possibility also?
Maximum. टू टू ठीक है.
Okay, so now let's see. If we use these two set, what will be the size of the set? It will be
2.
one only, no?
One.
Because
Only
a
one
set
different
contains only
element.
unique elements.
Unique elements.
If we take these two, then what will be the remaining? What will be the size of the set?
2.
2. If we take these two, what will be the size of
2.
set? 2. So 2 is the maximum length of the set we can have. Clear? Clear? Okay. So now let's move to the next example and try to understand what's written there. Okay. So here we have 1, 2, 3, 4, 5, 6. All 6 elements are unique here. 1, 2, 3, 4, 5, 6 in the first array, and 2, 3, 2, 3, 2, 3 in the second array. So what we can see that in second array we only have these two unique elements, 2 and 3. Okay. And in the first array, how many unique elements we have? How many unique elements we have here? 6.
6.
Right. So we have 6 unique elements here. So which all elements should I keep in the first array? We can keep 4, 5,
5, 6.
6. If we keep 4, 5, 6, these all elements won't overlap with the unique elements of the second array, and we'll have the maximum set length we can have, which will be 5 in this case, and the unique set will be 2, 3, 4, 5, 6. Clear? Now these are very short examples, but we should try to develop some method to these questions. What we can do? Okay, first of all, what I'll try to do is that I'll find out how many common elements we have in set 1 and set 2. Okay. So for this example, let's come to this example. How many common elements we have in set 1 and set 2? Let's count. How many common elements we have in set 1 and set 2? Right. We have 2 common elements in set 1 and set 2. Now, how many unique elements we have in set 1 and set 2? How many unique elements do we have in set 1? We have 6 unique elements in set 1 or array 1. and we have 2 unique elements in set 2 or array 2. Okay. Now what we will do is that we'll remove the common elements from both the arrays. I'll tell you what's the intuition behind it. First, what we'll do, we'll remove all the common elements from both the arrays, which are occurring in both the arrays. Okay. So which all elements are occurring in both the arrays, 2 and 3. So if we remove 2 and 3 from array 1, it will become 1, 4, 5, 6. And if we remove 2 and 3 from second array, it will become an empty array because there's nothing more in array 2 apart from 2 and 3. Only 2 and 3 are unique elements which are there in array 2, and we have removed all the common elements, and now it doesn't have any element remaining in that array. Is it clear? Ramandeep?
Yeah.
Okay. So now what we'll do, okay, we have selected those two elements, 2 and 3. We will include them in our final result for sure. We'll surely include them in our result. But what about these things? Like all the remaining elements we have in array 1 and array 2 are only present in either array 1 or array 2, right? So we must take them from them, right? If we don't select 1 from here, then we don't have any option of choosing 1 from any other side, right? If we don't choose 4 from here, then we don't have option of choosing 4 from second array. If we don't choose 5, we don't have option of choosing 5 from second array. If we don't choose 6 here, we don't have option of choosing 6 from the second array. But if we don't choose 2 from the first array, we still can choose 2 from the second array, right? Because 2 and 3 are present in both the arrays. So if we don't choose 2 from first array, we can still choose 2 from the second array. If we don't choose 3 from first array, we can still choose 3 from second array. That's a possibility. So keeping that in mind, what we'll do is that we'll keep aside all the common elements of the array 1 and array 2. Okay. And after that, we will count the number of unique remaining elements we have in the array. So in array 1, we have 4 unique elements. In array 2, after removing all the common elements, we don't have any element at all. So here we don't have any elements at all. So we have 4 unique elements in set 1, array 1, and 0 unique elements in array 2 after the removal. But from one array, we can choose at most how many elements? If an array is
N by 2.
right, if here our array is of size 6, so maximum unique elements we can choose is 3. Yes, 3 from an array. So we cannot, although we have 4 unique elements, we cannot choose 4 elements from that array, right? Because we can choose only n by 2 elements from that array to represent that array. So we'll choose only n by 2 and it will come out to be 3. Okay. Now coming up next, how many unique elements are still remaining in array 2? there are no unique elements remaining in array 2, right? So we cannot choose any element from array 2 after removing all the common elements. So now, how many elements we have in array 1 and array 2 combined after removing all the common elements? We have 3 elements in our final set. Now here we'll add our final common elements which we have removed from the set to this list, okay? And we'll get our answer. That total length of unique elements we can have is 5. Is the explanation clear, Ramandeep? Or we need more example?
Yeah, now able to visualize.
Okay. But still, let's look into another example. Let's look at this example, third example. So here, how many common elements we have in nums1 and nums2? We have no common elements. We have 0 common elements between nums1 and nums2. Is it clear? Because it has common unique elements 1, 2, 3, and it has unique elements 4, 5, 6. So we don't have any common elements in both of them. Is it clear? Right?
Yes, where?
So now, how many unique elements can we take from first array after removing the common elements, which is absolutely 0 here? So how many elements can we take from first array? 3, right? And 3 is exactly equal to n by 2. N is 6 here. So we can select 3 elements, and here we have only 3 unique elements. So we can select all the 3 of them. Then we'll go to nums2 or the second array. Here, how many unique elements we have? Here again, we have 3 unique elements. So we can select all 3 of them. So total size of the array of the final set, which we are getting, becomes what? 6. And there are no intersecting common elements between both of them. So we can't add anything else, and 6 is the final size of the array. Is it clear?
Yes.
Now let's take another example. This all examples seem very obvious. So let's take another example. 1, 2, 3, 4, and 1, 2, 5, 6. And let's make it bigger. 5, 7, 9, 10. Okay, so this is our first array. This is our second array. Okay. Now, first of all, what we'll do, we'll separate out the common elements of both the arrays. So what all common elements we have? So first of all, what is the size of the array? 1, 6. Array 2 is also again of size 6 only. Okay. So this is the size. And what all common elements we have in array 1 as well as in array 2? Let's check. We have 1, 2, and 5.
5.
These 3 are present in both array 1 and array 2. So we will remove them from our both the sets. Okay. So what is remaining in our first array? 4, 5, 7, 4, 3, 4, 7. What is remaining in our second array? 6, 9, 10. So how many unique elements we can take from here? 3. How many unique elements we can take from here? Again 3. Okay. So total, what is the size of the array we get by taking out unique elements from these two? It already becomes 6. Now we can't add further elements to them because at max we can choose n by 2 from both of the array. So we have already chosen n by 2, which is 3 and 3. So these all common elements, we can discard them. So we won't add them to our final answer. Is it clear? Or
Yes.
instead, you can add it also. 3 plus 3. This is the total number of unique elements in both the array after removing the common elements. And then after this, what you do? You add the common elements you have, which are present in both of the arrays. So this becomes 9. Okay. So total 9 elements 9 unique elements you have. Okay. But you can take max of n elements. So we'll take minimum of these two. And finally we'll get our answer. So is this clear? Is this approach clear? Hello?
Clear है. Clear है.
Okay. So this is a good question. And you try to solve it. You already are there. You are almost 80% into the problem. And if you will try for at least 30-40 minutes after this, you'll be able to code this problem. So let me ask all of you who are present here, if you have any doubt about use of maps. You both know about use of maps or hash maps, hash sets.
Yes, yes.
Okay. So you try using hash maps. You create different hash maps. Okay. For common, for elements after removing common from array 1, after removing common from array 2, and then what you do? Then you try to find out the best possible combination you can have. And again, we are almost 80% into the solution. All of you have understood what I have tried to convey, right? Or you have any further questions about the approach, like how we are approaching, how we are guessing the question? It is all clear?
Yes.
Okay. So I'll prompt you all to write the code for it because its coding is not very tough, and spend at least 10-20 minutes in deducing its logic and you will get through it. It's very simple question. And if you face any difficulty in coding part of the first or second question again, or the third question, then you can ask. Although you should not feel any difficulty because these are very standard question, the first two, and the third one again is a common standard use of set, which I guess you all will be knowing.